Alright, parallel and perpendicular lines. We're going to talk about comparing their slopes and writing equations of lines that are parallel and perpendicular to each other. In geometry, we would say that two lines are parallel if they are coplanar in the same plane and never intersect. Let's look in the room here and let's pick some lines that are parallel. If you just look at the grout between the blocks, are the lines upon the ceiling, or the lines between the tile and the floor. You see lines that are parallel that are on the same plane but do not intersect. What does coplanar mean? Well, if I look at this line right here on the floor, and on the other hand I look at that line that goes across the top of the room here at the corner, they don't intersect. This is going that way. This is going that way. Why don't they intersect? Because they're not in the same plane. This one's on the floor and that one's on the wall. What do you call them when they're not in the same plane and they don't intersect? Skew. So to be parallel, not only would we say that they don't intersect, but they are also in the same plane. So if we look at two vertical lines here on the floor, or on the ceiling, or on the wall, we could say that they are parallel lines. They're in the same plane, and they do not intersect. This symbol, which looks like absolute value bars right here, means parallel. Now, Euclid was the ancient mathematician that came up with the idea of parallel lines, that called them parallel lines, said that they were in the same plane and that they did not intersect. And from that, Euclidean geometry was formed. And when we talk about geometry in high school, or really on a college level, like if you're just getting your first degree there at BS, that's the kind of geometry that you study, is Euclidean geometry. So it's all based on his ideas. There are other forms of geometry, just to tell you this, there are other forms of geometry of people that did not agree with Euclid and thought that somewhere out there they would intersect. I know that makes no sense to you. So think about these railroad tracks. And if I'm standing way at the end of the railroad tracks and I'm looking way down there, way down the line, I can see a very far way, it appears that the railroad tracks are doing what? Appears they're getting closer to each other. And along that line of thinking, others thought that maybe parallel lines do exist, do intersect somewhere. And they didn't all consider a plane to be a flat surface like the floor or the top of your desk or something. Think about a globe of the world. What are those lines on the globe called? That go around, east to west, and lines that go north to south, what are they called?
Longitude and latitude.
Longitude and latitude. Now, if I'm not mistaken, and I'm sure no geography person, but longitude are the ones that go this way, north to south. Am I right about that? All right, now think about the lines of longitude on a globe. Do they intersect? Where? Where do they all go to? What do you call the top? North and south poles, okay?
Wait.
So they go through that point, all of them do. They go through the poles, and someone considered that globe to be, or that sphere, to be a plane, and they called it spherical geometry, and they said, well, those parallel lines do intersect. So there's other ways of thinking. There's some non-Euclidean geometry. But the kind of geometry that we've always learned is the Euclidean geometry, which says that parallel lines are coplanar and they never intersect. So if I had told you this morning, draw some parallel lines on your paper, how would you have done it? How would you have done it? Would you have made them vertical? Horizontal? Would they have a positive slope? Would they have a negative slope? Would everybody be right if they did? As long as they were on your paper, which is a plane, and they didn't intersect, we could call them parallel lines. So don't just think that it just has to be vertical lines that are parallel or horizontal lines that are parallel. You know, they can have positive or negative slopes and still be parallel. Now that's why we talk about parallelism in geometry. But in algebra, we have to say this. Write this down. If two lines have the same slope, now when we graph two lines, we graph them in the same plane, right? So that makes them coplanar. So two parallel lines that have the same slope are parallel. And then at the bottom of the page, it makes a totally separate statement that says this: all vertical lines are parallel. Why in the world are the vertical lines in a totally separate sentence? They've been set apart, and they're not included in our first definition up here about same slope.
Because vertical lines don't have slope.
Right. Because vertical lines don't have slope, so how could we talk about them having the same slope if they don't even have it? Okay? So this is an important statement to say too. Oh, and by the way, since vertical lines don't have slope, they're parallel to each other also. All vertical lines parallel to each other. And we can say the same thing about horizontal. Don't get me wrong. They all have a zero slope, but they all fall under here. They all have a zero slope, so since they all have the same slope, they're parallel to each other. All lines that have a 1/2 slope are parallel to each other. All lines that have a negative 2/3 slope are parallel to each other. All those things fall under our definition here. All right, we're to write an equation. We're to write an equation of a line that is parallel to this line, y equal 3x plus 7, and has a y-intercept of 4. Now this is like what we were doing yesterday. And I have enough information to write this equation in this. This is my problem. Write an equation of a line that is parallel to y equal 3x minus 7 and has a y-intercept of 4. Well, what's this got to do with the equation I want to write? Nothing except they have the same slope. How do I know they have the same slope? Because they're parallel. Okay, so the usefulness of this line here is just to tell me that the line I want is parallel to this one, and so they would, by definition, and I just wrote down, have the same slope. So what's the slope of this line right here, since it's in y equal mx plus b form? 3. So a line parallel would have the same slope. Okay. So I've got a slope of 3. Now, listen, guys. You remember yesterday we talked about if we were given the y-intercept and we were given the slope, which we are, what can we do? Plug them into what equation?
Point slope.
I could do point slope. I could. Because this is the point 0, 4. It is on the y-axis. What else can I do? Do you know? You remember from yesterday? Do you remember from yesterday? What can I do if I've got a y-intercept and a slope?
Could you do slope?
I can plug in the slope.
Not slope, but standard.
I'm going to go to slope intercept first.
Okay.
I can't just plug into standard, but guys, think about it. What does this represent?
Wow.
The y-intercept. Do I have a y-intercept?
Yes.
I mean, it calls it that, right? So I could go through this process. Y minus 4 equals 3 times x minus 0. This will, like she said, this will work for everything unless it doesn't have a slope, right? To plug in. What kind of lines don't have a slope again? Vertical. I can't do this with a vertical line. I don't have anything to plug in or slope. Okay. And when you don't have anything to plug in, by the way, when it's a no slope, don't just inadvertently choose a 0 and plug it in, because 0 is a number. And when it says no slope on vertical line, it doesn't have a number to plug in, okay? So with a vertical line, I can't use this, but I can use this on everything else. By the way, what's 3 times 0? Do I have to write that? It's a 0. And then to solve for y, I would add 4 to both sides. Y equal 3x plus 4. What I was trying to get you to see, and this is, she's exactly right, you can use this in every case, but what I was trying to get you to remember from yesterday was that if I've got an M and I've got a B, can I just plug them in? If the point I'm giving is a y-intercept. Now, if this point had been like 2, 4, could I use the shortcut method? No, because that's not B. That's over in the first quadrant. That's not on the y-axis. I would have to use point slope. But if I have a y-intercept, I can just go straight to here. All right, put that equation, whichever way you're looking at it, here or here, they're the same. Put that in standard form. Put that in standard form. Make it look like this. Okay, let's put it in standard form. Yeah, just go from here. Put your X with those. Y'all agree?
Yes.
Oh, you know. Okay. Now that's standard form. All right, looking back through that problem, and I know your problem's given to you in words, okay? But that's what it's going to be on our end of course test too, right? So looking back through there, I feel like we understand this, but I'm not so sure we remember this from yesterday. Don't get confused. This only can be used when you have a y-intercept. Not if you have something like this, you can't use that shortcut. Okay? I feel like we're not getting that. Let's just try another one. Let's look on the bottom of page under example 1 on page 259. It says write an equation in slope-intercept form of a line parallel to y equal 0.5x plus 5 and has a y-intercept of -2. Okay, now remember, what's the usefulness of this right here, this equation? I'm giving information that my line I want is not this one, but it's parallel to this one. So what can I do? Somebody tell me. Slope. I can find slope. So the slope of this is a half. I'd rather use that than the decimal. So this slope is 1/2. So a line parallel to that is also going to have a 1/2 slope. I have a y-intercept. Can I use a shortcut? Can I plug straight in for M and B? If I did, what would I get? Y equals
1/2 x
plus a -2, so it's -2, good. If I did not think of that, I could also use this. Practice using that one. Plug in your 0, -2, and your 1/2 into point slope form. We're plugging into this one to see that we get the same thing. This is a y-intercept, so this is like 0, -2, so this is that's right. Y'all see it in there. So y plus 2. And then put it slope form. Mm-hmm. Good. Y equal 1/2 x minus 2. Mm-hmm. That's what it is. Mm-hmm. Good job. That's all you had to do. Does anybody have a question?
Or is that Y plus two?
All right. This half right here.
No, the one's under Y plus two. The other one, go the other way. The other way. Does that say Y plus two?
It is.
Okay.
Yeah, y plus 2.
It looks like it said when.
Okay,
Well,
that, yeah,
yeah.
y plus 2 equals 1/2 x. Where did I get my 1/2 slope from?
0.5.
0.5 is the same thing, right? And my lines are parallel. But do you guys see that this only works when I have a y-intercept, this works all the time, but they should give the same answer, I'm working the same problem, right? Alright, are you ready to do standard form? The usefulness to this equation right here is only to say that the one I want is parallel to this one, okay? So if let's say I have a sheet of graph paper, I'll just do one. And I have the equation that they gave me, y equal 1/2 x plus 5. Okay? So I go up 1 and to the right 2, I go down 1 to the left 2. On and on. Stretch it all the way across the coordinate plane. This was the line, like you said, that they just gave me. Then, she wrote an equation just a minute ago, y equal 1/2 x minus 2, is that right?
Mm-hmm.
And so here it is. There's something crazy. Does that look okay? Does it look parallel?
Yeah.
Okay, it's hard to tell up there. Okay. So it's just saying they have a relationship and they're parallel to each other. I'm looking for a line that goes through this point and is parallel to that line. You're like, okay, fine. Put that point down there and use the same slope and you've got it. And on a graph, it's kind of easier to see. But when we're writing an equation, we just want to make sure they have the same slope, and that's the only usefulness of that line. Okay? Yes. The plus 5 goes nowhere. It's a totally separate line. Okay? Alright, come to standard form for us. Okay, come over here and subtract 1/2 x from both sides. So I have negative 1/2 x plus y equals, and these two canceled out and left me with minus 2. Okay, now, it's almost standard form except I have a negative and a fraction. So put this whole thing in parentheses. What would you multiply by? Negative 2. You gotta get my denominator also. Okay, so multiply everything by negative 2 and you'll have it in standard form. You don't need this. What's half of 2? 1. 1x. And the negative times negative is a positive, right? Negative 2 times y. Just negative 2y. And then negative 2 times negative 2. Positive 4? Negative 2 times negative 2. So that'll be a 4. Positive 4. Standard form. Alright, let you fix that on your paper, okay? Alright, so x plus 2y equals 4. Now that's standard. A few minutes ago, she gave us slope intercept up here. So we start out with point slope, if we do it the long way. We start out with point slope, then we get to slope intercept, and then we finally get to standard, okay? Can we just plug straight into standard? No. Not in any case. But the only time we can plug straight in to slope intercept form is when we have an intercept. We have the y-intercept, and that's the only time. Let's keep working some examples, okay? Alright, let's say that I am going to write the equation of a line that is parallel to y equal 3/2 x minus 5. And the line that I want doesn't go through -5 on the y-axis. But what it does go through is this point 5, -4. Is this 5, -4? Is this a y-intercept? No. It's in what quadrant? 5, -4. Fourth quadrant. It's not a y-intercept. Alright, so can I use that shortcut?
No.
No, I cannot. Good. Alright, so I have to go to here. What slope will I use? 3/2. Why? It's in front of the x, right? In my line, I want it's parallel to this one. That's what this symbol means. All right, so the line that I'm given has a slope of 3/2. The line parallel to that has the same. All right, so here's x1, y1, and here's the slope. So let's substitute in and find the slope intercept form like we were doing yesterday. On your paper, once you get it in slope intercept, go on to standard. Can you put it standard? Let's look at what he did so far. Right down is y plus 4, 3/2 times x, 3/2 times 5. Just numerator times numerator. This is a whole number, denominator times denominator. So that is a -15/2, which if you did -15/2, -7.5, or -7.5, those are all the same thing. And then he subtracted 4 from both sides and got y equal 3/2 x minus 11.5. Which you may have left 11.5 as 23/2. That's probably what I'd do. But so you could have -11.5, -11.5, -23/2. X up there, that 3. 3x minus 2y equals 23. Is everything right, including your signs? It's all good? Anybody have questions? Is it getting easier?
Yes.
A little bit? We just have to practice these, that's all there is to it. Alright, I need the equation of a line that goes through, or excuse me, is parallel to 2x plus 3y equals 6. But that goes through -2, -3. So -2, -3 is not on that line that was given. The line I want does, but it's parallel to this one. Now I have to ask you a question, huh?
That's in standard form.
That's in standard form, and so how do I find its slope? I could put it in slope
A
intercept.
over B, negative
Right.
A over B.
Negative A over B is the little formula, so what's the slope of this line? Huh? Negative 2/3, yes. So that goes back to what we've been doing for a while, finding the slope in standard form. Alright, so now -2/3, is that a y-intercept? No, so I can't use the shortcut. So we're going to use point slope form. Alright, plugging in what you know, find the slope intercept in standard forms of this equation. Okay, what he did here, he plugged in his -3, that made a +3. He plugged in his -2/3 and his -2, and the opposite of a negative became a plus. This is a +2. Now when he multiplied that by -2/3 though, -2/3 times x and -2/3 times 2 is -4/3, and some of you got -1 1/3, and that's the same thing. Just don't do -1.3 because it's not 1 3/10. It's 0.3 repeating, you can't write that, so just leave it as a fraction. So then, since this was a +3, he subtracted 3 from both sides, and you either got right here -4 1/3, or as he did, -13/3. And that is slope intercept form right there. Alright, are there questions? Raise your hand if you got that. Wow, about half, okay. So, questions from anybody? Would you put an X right there? I didn't notice that. Well, it should be up to the 2, right? It's not there, it's on there. Alright, keep going, keep going. Do what now? Yeah, it is. Okay, so you're just rewriting it. I gotcha. I gotcha. habit, isn't it? But yeah, the X is really in the numerator. This is not a rational graph. Good. Notice that you didn't need a negative this time, right? You just had to multiply by 3. You don't just multiply by a negative if you don't need one, right? Alright. The 3's cancel. Give you 2x. 3 times y is 3y. This is that negative 12 plus 1, negative 13 thirds. So when I multiply those, the 3's cancel and leave me with a negative 13. Standard. Raise your hand if you had this. Oh, many less. Many less. Does anybody have a question? Question. If you just leave it improper, then you just like see the 3's cancel and leave it with a negative 13. If you leave it mixed, you have to make it improper if you're doing it in your head. And then multiply it by 3. If you got a calculator with a fraction button, you don't care. It does all that for you. Okay, any other questions? Yes. When you decide what number to multiply out here on the front, you just use, like if you've got more than one denominator, use the common denominator. These are the same. That's happened a lot in all our problems. So yeah, you just choose the common denominator, which there was just one. Yes, ma'am.
Why didn't you do a negative 3?
Good question. Because I did not need to change the x, it was already positive, and so I kept it there. The only purpose of multiplying by a negative is to change a negative into a positive, and I already had positive.
Because I thought
Yeah,
you
I
were
put a
doing
negative
negative
three.
because that negative 4.
That is a very good question. I'm glad you asked it, because I said that before, and I could tell nobody really responded, so you asked it, and she's like, oh, okay. So if this is negative, I need a negative out here. If this is positive, leave it alone. If these don't have any fractions in them, don't multiply by a number either. You know, it's just whatever you need. Alright, now let's talk about perpendicular. Use your arms and show me perpendicular lines. It's a cross, isn't it? Okay? So what kind of angle is formed by perpendicular lines? A right angle or a 90-degree angle. In geometry, that's what we would say. Perpendicular lines form 4 right angles. Here they are. This is like a railroad sign, and these are right angles in here. Now this upside down capital T is what it looks like to me, is the symbol for perpendicular lines. So when you see that, that's what it means. And instead of writing perpendicular every time, we're just going to use the mathematical symbol. Okay, so this symbol means perpendicular. In geometry, right, lines form 90-degree angles. That is true. But I'll let you write that down, and then we'll talk about what it means in algebra. All right, in algebra, if the slopes of two lines are negative reciprocals of each other, then the lines are perpendicular. What does that mean? What's an example of a reciprocal? What's the reciprocal of 1/2? 2/1. What's the reciprocal of 2/3? 3/2. What's the reciprocal of 4?
1/4.
All right, so if I say negative reciprocals, what that means is one of them positive and one of them negative. They have opposite signs, okay? For example, these two lines here, one of them has a positive slope, one of them has a negative slope.
Wait, so it's like 1/4,
Like
and the reciprocal would be -4/1?
Yeah.
Okay.
Like the slopes, instead of being the same, are going to be opposite reciprocals of each other. One will be positive, one will be negative.
Okay.
All right, good question. All right, now I had to, make a special statement for vertical lines because they don't fall under anything talking about slope. So all vertical lines are perpendicular to all horizontal lines. Look at your notebook paper. You see a long pink vertical line, right? Or red, it depends on your paper, I guess. And then you see many blue horizontal lines, and they are perpendicular to that pink or red line. All right, so all vertical lines and all horizontal lines are perpendicular to each other.
Okay.
That works too. Alright, now, this is very similar to what we've been doing all day, and I've got time for a couple of examples. Write an equation of slope-intercept form of a line that has a y-intercept of 4. Okay, can I use the shortcut?
Yeah.
Okay. That is, now look at this word, perpendicular to this line. Now this line has a slope of 3. A line that I want is perpendicular to that. It would have a slope of what?
Negative
Negative
1/3.
1/3. That is the only difference between parallel and perpendicular. You find the slope of the line you're given, then you flip it and change the sign. So if this slope had been negative, my slope I'm going to use would be positive, right? Now this works the same way, and you told me I could use the shortcut, so I'm going to plug in my slope and my y-intercept. Would I have gotten the same answer if I'd used point slope? Yes. The only reason I can use the shortcut is because this point is a y-intercept. That is it. Alright, let's go to standard. We're going to add 1/3 x to both sides. 1/3 x plus y equals 4. Which gets us to the question I was asking a few minutes ago. What do I multiply this whole thing by? How do I decide?
3.
Just a 3, because I only have a fraction. I don't have a negative with my x, so I don't want to change it. So I multiply by 3. The 3's cancel x, 3 times y, and 3 times 4. Now this is standard. And way up here I had slope intercept because I could use my shortcuts.
I think standard is.
I like perpendicular.
Standard's
but-
easy,
Perpendicular, you just have to remember, change the sign, flip the slope, it all works the same way.
I think we should go over this one tomorrow.
For fun?
Yeah.
We got it today.
We need
Alright, let's
dollars.
look on page 260 under example 2.
Wait, where are we at?
Underneath example 2 on page 260. Alright, so this is a 6 even though it looks like a B. Can I use the shortcut? Yes.
Yes.
Yes, because that's a y-intercept. What is the slope of this line?
Negative. No.
4.
4.
But you started to tell me the perpendicular would be
Negative 4. 1/4.
good. Alright, use the shortcut and write the slope-intercept form. What would it be?
Y equals
Negative 1/4 x
plus 6.
plus 6. Okay, go to standard. What would I do to both sides?
Add 1.
So 1/4 x plus y equals 6. What would I multiply by?
4.
Good.
X plus 4y equals 24.
You know what people do to miss it, honestly? They bring
The
down that
6.
6. You
Yeah.
gotta remember everything
24.
multiplied by 4. That's standard.
You know what I do every single time? I'll just write y instead of like 4y.
Uh-huh. Yeah, and I've noticed some of you guys canceling this thing out. You know what you're gonna do? You're gonna do like she's saying, you're gonna forget that those get multiplied by 4 also. Okay?